Welcome everybody. This is our fourth class in NEET previous year questions, fourth chapter, electrostatic potential and capacitance. This is a subtopic related to class 12 chapter known as electrostatics. Before in this series, we have made three videos and all of those videos are available on our YouTube channel's playlist sections. And there is a dedicated playlist for these type of videos and name of that playlist is or title of that playlist is NEET previous years. We have also started similar series for JEE mains previous years, so you can go to our channel and check those videos also out. And again, if you find these videos useful, then you can press the like button, share them, and subscribe to our channel. It helps a lot. Also, if you want to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With your donations, we will be keep on making these videos on a regular basis. So let's start today's video. Now, in previous video, we covered up to question number 35. This was the last question. And let's start today with the next one. Let's adjust pen thickness. So, yes, visible. A parallel plate air capacitor has capacity C, distance between plates D, potential difference V applied across the plates, force of attraction between the plates of the parallel plate capacitor is. So यहाँ पे हमें रिलेशन बताना है कि जो फोर्स है वो किसके प्रोपोर्शनल होगा। और अगेन सेम क्वेश्चन हमने जस्ट प्रीवियसली यहाँ पे सॉल्व किया है कि जो फोर्स था प्लेट्स के बीच में वो आइदर क्या वो एप्सिलॉन बाय क्यू सिग्मा बाय 2 एप्सिलॉन नोट था और क्या स्क्वायर बाय 2 एप्सिलॉन नोट था। और बाद में हमने उसको चेंज करके सी स्क्वायर वी स्क्वायर बाय 2 एप्सिलॉन नोट में कन्वर्ट कर लिया था। सो लेट्स सी कि जो हमारा क्वेश्चन है हम उसको किस फॉर्म में लेके आ सकते हैं। सो जो हमारा आंसर है यहाँ पे सी और वी की फॉर्म में है। तो अगर हम सी और वी की फॉर्म में देखें तो हमारे पास आई थिंक जो पॉसिबल सॉल्यूशंस हैं, एक हमारे पास ये पॉसिबल सॉल्यूशन है, हम इसी को मॉडिफाई करेंगे स्लाइटली। सो लेट्स कॉपी। और ये सॉल्यूशन यहाँ तक हम कैसे पहुंचे हैं ये आप हमारी प्रीवियस वीडियो के लास्ट क्वेश्चन में जाके देख सकते हैं कि हम यहाँ तक कैसे पहुंचे थे। यहाँ पे इलेक्ट्रिक फील्ड हमने कैसे ली थी, बाय 2 वाली क्यों ली थी और सिग्मा बाय एप्सिलॉन नॉट क्यों नहीं लिया था, वो हम सब कुछ प्रीवियस वीडियो में डिस्कस कर चुके हैं। सो लेट्स पेस्ट इट हियर। सो ये हमारे पास फॉर्मूला आया था और अभी हम यहाँ पे क्या कर सकते हैं, बिकॉज हमें सी वी और डी की फॉर्म में बनाना है तो यहाँ पे ये एक सी को हम वैल्यू पुट कर सकते हैं और बाकी सी को एज इट इज रख सकते हैं। कैसे? ऐसे दैट इट विल बी माइनस, लेट मी मेक इट स्लाइटली मोर। सो हम यहाँ पे अगर माइनस एज इट इज रखते हैं, एक सी की वैल्यू हम पुट करते हैं एप्सिलॉन नोड ए बाय डी और बाकी एक सी को एज इट इज रखते हैं सी वी स्क्वायर बाय 2 एप्सिलॉन नोड ए। सो एप्सिलॉन नोड से ये कैंसिल हो जाएगा और हमारे पास ये बच जाता है माइनस सी वी स्क्वायर बाय 2d। और यहाँ पे हमारा जो ऑप्शन बी है, ऑप्शन बी बिकम्स द राइट आंसर। नाउ मूविंग टू नेक्स्ट क्वेश्चन। A parallel plate air capacitor is charged to a potential difference of V volts after disconnecting the charging battery. Distance between the plates of the capacitor is increased using an insulating handle. As a result, potential difference between the plates. So यहाँ पे देखिए कि आफ्टर डिस्कनेक्टिंग द चार्जिंग बैटरी मीन्स आपने बैटरी को डिस्कनेक्ट कर दिया सर्किट से और कैपेसिटर से भी। सो अगर आप बैटरी को डिस्कनेक्ट कर देते हो तो हमारे पास क्या होता है, जो चार्ज है चार्ज रिमेन्स कांस्टेंट। सो अगर चार्ज कांस्टेंट है आपके पास सो क्यू इज इक्वल टू सी वी होता है। और जैसे ही हम जो बैटरी प्लेट्स हैं उनके बीच के डिस्टेंस को इंक्रीज करेंगे तो जो हमारा कैपेसिटेंस है, वी नो कैपेसिटेंस इज गिवन बाय एप्सिलॉन नोड ए बाय डी। तो अगर आप डी को इंक्रीज करोगे तो जो कैपेसिटेंस है दैट विल डिक्रीज। सो अब इस जो हमारी इंफॉर्मेशन है इसका यूज हम यहाँ पे करते हैं। सो क्यू बाय सी इज इक्वल टू वी यहाँ से, और बिकॉज हमें ये पता है कि जो क्यू है इट इज कांस्टेंट, और जो सी है ये हमारे पास डिक्रीज हो रहा है बिकॉज हम प्लेट सेपरेशन इंक्रीज कर रहे हैं। सो एज ए होल जो अगर आपका डिनोमिनेटर डिक्रीज होने लगता है, इट डज मीन दैट एज ए होल दो जो रेशियो है रेशियो विल इंक्रीज। सो पोटेंशियल विल increase. Moving to next question. Capacitance of a capacitor with charge Q and a potential difference V depends upon. So कैपेसिटर्स का कैपेसिटेंस बताना है, चार्ज मेंशन है और उसका पोटेंशियल डिफरेंस मेंशन है। सो वी नो दैट Q is equal to CV, and here C is given by epsilon node A by D. If neither area changes nor the distance between the plates changes, in that case scenario we can say C will remain constant if plate area and distance does not changes. So what does it mean? That it's neither depends upon Q, neither depends upon the V, it's only depends upon the area and the distance, means geometry of the system. So option B, the geometry of the capacitor, that decide that what will be the capacitance, and it will either increase or decrease. That only depends upon the changes in geometry of the capacitor. Next question. So parallel plate capacitor having cross sectional area A and separation D has air between the plates. Now an insulating slab of same area but thickness D by 2 is inserted between the plates as shown in the figure, having dielectric constant 4, ratio of new capacitance to its original capacitance. So let's start. Suppose this is our initial capacitor. It has area A and separation D, and there is no dielectric material inside the plates, means only air is there. So in this scenario, original capacitance C node will be given by epsilon node A by D. Now, as per mention that we inserted a plate here. So suppose this is the plate as already mentioned in the diagram here. So this system has area A for both of the plates equal, means for this plate area is A and for this slab area is also A. But thickness of the part of the capacitor where air it's D by 2, and thickness where we have inserted the slab it's D by 2. So this system will work like a two capacitor, both are in series. First capacitor has air inside it as a material, has a thickness D by 2 and area A, and in series with there is second capacitor which has a dielectric material of dielectric constant K is equal to 4 inside it and thickness D by 2 and area A. Now let's assume this capacitor is C1 and this capacitor is C2. So C1 will be epsilon node A D by 2 and 2 goes above. So 2 epsilon node A by D, and C2 will be epsilon node into K's value is 4 into area divided by D by 2 and 2 goes above. So it will be 8 epsilon node A by D. Now as both of these capacitors are in series, so their final capacitance we can say C dash will be given by 1 by C1 plus 1 by C2. So 1 by C dash is equal to d by 2 epsilon node A plus d by 8 epsilon node A. From this we can copy d by epsilon node A, take common, and it will be 1 by 2 plus 1 by 8. And using LCM, it will be 8, 4 plus 1, d by epsilon node A is equal to 1 by C1. Reversing it, what we get, C1 is equal to 8 by 5 epsilon node A of D. And if we compare this value, epsilon node A by D, from the value with which we started, so it is epsilon node A by D is equal to C node. So C1 is equal to C 8 by 5 of C node. And what we have to find, the ratio of C1 versus C node, ratio of new capacitance to original capacitance. So C1 by C node will be 8 ratio 5, and option B matches the answer. Moving to next question. Capacitance of a parallel plate capacitor with air as a medium is 6 microfarad. With the introduction of a dielectric medium, capacitance becomes 30 microfarad. Permittivity of the medium is, so we have to find out permittivity of the medium. So now in this question, it is not mentioned that when we introduce that dielectric material or dielectric slab inside the capacitor, uh, that whatever it occupied, uh, full space or some partially, it occupied some partially, like this, that if this is our original capacitance, either it's occupied full space between the plates, or like previous question, it occupied some space, some ratio of space between the plates. As it is not mentioned, so what we consider that it has occupied completely, and in that scenario our new capacitance C becomes K times C node, where C node is the old capacitance without the plate and C is the capacitance with the plate. So with plate it is 30 microfarad, K is equal to 6 microfarad. So from this K comes out to be 5, and we have to find out the permittivity. So permittivity will be epsilon will be K times epsilon node. So 5 times 8.85 into 10 raised to power minus 12. So this will be 25, 42, 42 with 2 points here, and in 10 raised to power minus 10. So we can say 0.42 into 10 raised to power minus 10, and it matches with this option, option B. There can be some value changes after decimal, because it depends upon the how many decimal points they have taken for their calculations. So your answer can slightly change, but on the broad range or decimal wise, or the first decimal at should match, at its first decimal point should match. Moving to next question. Two thin dielectric slabs of dielectric constant K1 and K2 are inserted between the plates of a parallel plate capacitor as shown in the figure. Variation of electric field E between the plates with distance D as measured from the plate P. So measurement is done from plate P, each shown by, and these are dielectric slabs, not conducting slabs. These are dielectric slabs. So this is a dielectric slab and this is a dielectric slab. So let's start. Now we know that from the basic theory, that electric field inside a capacitor, between the capacitor plates, is given by sigma by 2 epsilon. And when you introduce some dielectric material, this epsilon changes. And in that scenario, E becomes E dash, and epsilon node becomes epsilon, or we can say it becomes sigma by K times epsilon, where K is the dielectric constant of the material. And it is usually greater than 1. So if we introduce some dielectric slab, electric field, this E dash represents a electric field inside slab. So if we mark here the empty space between P and this slab, here electric field value will be E node, and E node is equal to sigma by epsilon node. Inside this slab, electric field value will be sigma by epsilon, or we can say it is like E node by K. So inside this slab, it value will be E node by K, and for this K value is K1, so E node by K1. Now again there is empty space, so electric field will be again E node. For this slab again electric field will be E node by K1, and for this area again electric field will be E node. Now as K1 and K2 are greater than 1, so electric field inside these slabs will be slightly lesser as compared to the original electric field or E node. So our graph should go downwards. And now also mention that K2 is greater. K2 is greater than K1, and we can say E1 electric field inside the first slab, which is E node by K1, and E2 electric field inside the second slab, that will be E node by K2. As we know K2 is greater, so we can easily say that E1 will be greater than E2. Now if we can if you plot a diagram, a graph here, and this value represents E node value, or E node sigma by epsilon node, and this represents the separation. This is the total separation. Now from P, let's mark say some points A, B, C, D, E, and F. Now from A to B, electric field value will be E node. Then B to C, electric field value will decrease slightly as it is divided by K1. So it will decrease slightly. So it is decreased, and it will stay decreased up to C point. So it will stay decreased up to point C. Then it will come back to original value up to point D. Then it will again decrease as it again we encounter a slab, and inside a slab electric field value reduces as now K2 is greater than K1, so E2 will be slightly lesser than E1, so there will be a larger dip, and it will again come back to original value, and this is point F. If we mark the points A, B, C, D, E, F. So this will be the this will something plot will look like, and if we can try, there is option C which resembles with this plot. So option C will be the right answer. Moving to next question. Two parallel metal plates having charge plus Q and minus Q faces each other at a certain distance between them. If the plates are now dipped in kerosene oil tank, electric field between the plates will. Now, as it mentioned that these are two parallel metal plates, and we will consider that these are infinite plane sheets, because only then we can say that electric field between them will remain constant. So, as first sheet has positive Q charge and second sheet has minus Q charge, if their area is A, then we can say electric field will be sigma by epsilon node, or Q by A epsilon naught. This will be the electric field between these two plates. Now, if we insert them in a kerosene oil tank, so the area between these plates will be occupied by kerosene oil. This will be the oil, and as a material property, this oil will have some value of dielectric constant K, and this K is always greater than 1. Hence, electric field inside, when the plates are dipped in kerosene oil, the electric field will become E dash will becomes E node by k, and if, as already known that k is greater than 1, so denominator value is greater than 1, so E dash will reduce, so electric field value will decrease. Option C will be the right answer. Moving to next question. Parallel plate capacitor with oil dielectric constant 2 between the plate has a capacitance C. If the oil is removed, the capacitance becomes. So C is equal to uh, capacitance is C when it has a dielectric material which has a dielectric constant of 2. So it will be 2 times epsilon naught times A times D. Now, if we remove this dielectric material, then dielectric capacitance C dash will become epsilon node A by D, because if we remove this dielectric, then there will be only air left, and air has a dielectric constant of 1. So from this we can find out, if we divide both of these, then C by C dash it will become 2, and from this C by 2 is equal to C dash. So if we remove the oil, then new capacitance will be C by 2. Option D. Moving to next question. In the following circuit, equivalent capacitance between the terminal X and Y will be. Now, if you seen Wheatstone bridge, then you can, if you just remember these are not capacitors, these are resistances. So in that scenario, it is a balanced Wheatstone bridge, and if Wheatstone is balanced, then this middle connection, there is no current flows through this middle wire, and if no current is flowing through this middle wire, then we can easily remove this wire, and so our circuit will look something like this after removing this wire or this capacitance also. So we'll have 2 microfarad capacitance, 2 microfarad, 2 microfarad, 2 microfarad, and this will be the final simpler circuit. Now these 2 and 2 are in parallel, so when they are added, oh sorry, series. These 2 and 2 are in series, so when they are added, they will give 1 microfarad, and also these two capacitors are also in series, both of each equal value. So they will give 1 microfarad capacitance in series. Now both of them, this one and this one, are in parallel. So in parallel they will give 1 plus 1 2 microfarad. Option D will be the right answer. Moving to next question. Equivalent capacitance of the system shown in the following circuit. So here you can see that this 3 and this 3 both are in parallel. So when the capacitors are in parallel, they are simply added. So 3 plus 3 will be 6. So this will be 3, and 3 plus 3 is 6. Now both of are in series, so they will be added in 1 by, in the inverse. So 6 to 1, 3 by 6, 1 by 2. Now take inverse of 1 by 2, that is 2. So answer will be 2 microfarad. Moving to next question. Equivalent capacitance of the combination shown in the figure. So again, this is a similar question, and we can see that if you look carefully for this capacitor, both of its terminals, both of its points, these 2 points are joined with one another. So effectively, both of its points are at same potential, or and if both of the points of a capacitor are at same potential, so this capacitor will not work. So we can remove this capacitance, and our effective circuit will look like something this CC, and we have removed this connection. Just we done this, so this we have removed this connection. We will be only left with CC and their parallel combination. Now both of are these in parallel, so C plus C will be 2C, and option B will be the right answer. Moving to next question. So a parallel plate capacitor of area A, plate separation D, and capacitance C is filled with four dielectric material having dielectric constant K1, K2, K3, K4 as shown in the figure. If the dielectric material to be used, if a single dielectric is to be used, so suppose we have to use a single dielectric here, then we have to find a relation between the value of that single dielectric and these dielectrics combined capacitance. So let's start. Now if you can see, this is the plate thickness D, and we have connections like something here. We will have connections because area, plate area is mentioned here and plate thickness is mentioned here. So this is a capacitance with dielectric material K1 having area A by 3 and thickness D by 2. Same for K2 and K3. These are the capacitors with area A by 3 and thickness D by 2. And all of three are in parallel. And now we have another capacitor of dielectric material K4 with area A and thickness D by 2. And this capacitor is in series combination with combined parallel combination of these four. So we have something like this. We have a capacitor with K1 material in parallel with K2 material and in parallel with K3 material, and all of these three in combined are series with capacitor with K4 material. And for this K4 we have area A, thickness D by 2, and for all of these three we have area A by 3 and thickness D by 2. So what we can do, we can first we will find the individual capacitance CK1, CK2, CK3 and CK4. So CK1 will be epsilon node, area is A by 3 and thickness is D by 2. So it will be 2 by 3 epsilon node A by D. Similarly for CK2, and we forgot K1. So K1 will also be here. For K2, it will be 2 by 3 epsilon node A, K2 by D, and for K3, same value, just dielectric value will change, epsilon node A, D, K3, and now for CK4, we will have K4 times epsilon, area is A and thickness is D by 2. So it will be 2 epsilon A D into K4. Now CK1, CK2 and CK3, K1, K2, K3, all of these are in parallel. So their combined capacitance, we can say C dash, will be their normal sum, their algebraic sum. So it will become 2 by 3 will be common, epsilon node A by D will be common from all of these. So it will be 2 by 3 epsilon node A by D bracket K1 plus K2 plus K3. This will be their combined sum. So we can represent it something like this. C dash and K4. Now this C dash, which is combined sum of K1, K2, K3, is in series with capacitor having dielectric material K4. Now if as they are in series, so we will add them in inverse. So let's add them and say, let's say that final capacitance is CF. So 1 by CF will be 3D by 2 epsilon node A, K1, K2, K3 plus for this D by 2 epsilon node A, K4. Now we can take D by 2 epsilon node A common. So D by 2 epsilon node A common. It will, we will be left with 3 by K1, K2, K3 plus 1 by K4. And from this we can write 1 by Cf is equal to d by 2 epsilon node A. Let me check the answer that in which form we have to represent. Okay, so we have to represent in by form. So we don't take LCM here. What we do, we just take inverse. From this we can write that CF, C final, will be epsilon node A by D, 2 epsilon node A by D, and inverse of 3 by K1, K2, K3 plus 1 by K4, inverse of this. Now, as it is asked that we have to replace these all dielectrics with a single dielectric of capacitance of dielectric constant K. So, if we have replaced all of these dielectrics with a single material of dielectric constant K, then its capacitance will be given by epsilon node K times epsilon node A by D, and it should be equal to Cf because this whole system is equivalent to our original system. So now if we compare that, as per mention, this Cf should be equal to epsilon node A by D from this into K. From this, by comparing this value and this value, we can easily write that K is equal to 2 times 3 by K1, K2, K3 plus 1 by K4 inverse, and from this K by 2 is equal to 3 K1, K2, K3 plus 1 by K4 inverse. Now taking inverse power of both of sides, so from this side inverse will get cancelled and this will revert. So we can say 2 by K is equal to 3 by K1, K2, K3 plus 1 by K4. And now let's copy this and now let's compare, paste. If you can see that our option C, 2 by K is equal to 3 K1, K2, K3 plus 1 by K4 matches with answer. So option C will be the right answer here. Now with this, we end this video here. Hopefully whatever we have covered is helpful to you. Again, if you have any doubts or suggestions, you can put them in comment section. I will try to solve them or implement your suggestions. And again, if you like this video, please share as much as possible, press the like button and subscribe to our channel. And if you can make some donations, if it is possible, amount does not matter, then you can scan these QR codes and donate us with whatever amount you want. Even your small donations help us or motivate us to keep this series ongoing on regular basis. So with this, I take leave for today, and we will meet again in the next video. And at last, thanks for watching.